Welcome to the November installment of the American Journal of Physiology, Heart and Circulatory Physiology Video Table of Contents, or From the Editor's Desk. By now, the presidential election in the U.S. is over. It's been a long ordeal. At the time of this taping, I don't know the outcome yet. But whoever is elected, we all have to work hard to tell our governments how important it is to support biomedical research. Now let's get down to the important stuff. This month, we've published an issue that contains 2 reviews, 22 original research papers, and 1 letter to the editor. So let's see what's inside. We have had the privilege of publishing the annual Robert Byrne Lecture this year. Stephanie Watts of Michigan State University describes the important cardiovascular roles of serotonin. She provides a historical overview as well as a description of how serotonin may play a role in blood pressure reduction and hypertension with a focus on the venous circulation. You'll enjoy this. In a second review by Toth et al., the mechanisms responsible for impaired cerebral autoregulation after traumatic brain injury are reviewed. The review focuses on functional, cellular, and molecular changes of autoregulatory function of cerebral blood flow. This review will prove useful for vascular and cognitive biologists alike. Benjamin et al. Study an issue related to catecholamine cardiac toxicity. They evaluated the effects of elevated levels of dopamine in H9C2 cardiomyoblasts. Lipid accumulation, cell viability, and reactive oxidant species, among other parameters, were examined. After 24 and 48 hours, dopamine induced a significant increase in lipid accumulation, nitrotyrosine, and cell death. Dopamine reduced flippase activity and ATP-GTP ratio. NOx expression was also increased. All of this may contribute to cardiac inflammation and reduced function in catecholamine overload. Gonzalez et al. Hypothesized that in angiotensin II-induced hypertension, genetic deletion of galectin-3, or GAL3, prevents left ventricular adverse remodeling and left ventricular dysfunction by reducing the innate immune responses and myocardial fibrosis. Experiments were carried out in GAL3 knockout mice infused with angiotensin for 8 weeks. Compared to wild type, GAL3 knockout mice exhibited blunted hypertrophy and fibrosis as well as ICAM1 and plasma IL-6. Hypertensive GAL3 knockout mice also had a higher number of splenic T-regulatory lymphocytes. This study indicates that the Ang2 effects are in part mediated or triggered by GAL3, leading to cardiac inflammation and fibrosis. Finally, Hamid et al. Determined the effect of the TNF-alpha receptor signaling pathway on cardiac stem cell differentiation. They hypothesized that TNF differentially modulates cardiac stem cells in a TNF receptor-specific manner. Using wild-type and TNF1 and TNF2 receptor knockout animals, the results indicate that TNF signaling in murine cardiac stem cells is constitutively related primarily to TNF receptor 1, with TNF receptor 2 inducible after stress. TNF receptor 1 signaling reduced cardiac stem cell proliferation, but also with TNF receptor 2 augmented cardiac stem cell resistance to oxidative stress. Importantly, TNF receptor 1 inhibited cardiomyocyte commitment during cardiac stem cell differentiation and instead promoted smooth muscle and endothelial fates. Thank you for watching and listening to the November From the Editor's Desk. Enjoy the rest of the fall in the Northern Hemisphere, and we'll see you next month. Please watch our recent and upcoming calls for papers, and please send us your best work now.